By the time the doors opened at the Frankfurt and Geneva motor shows in 1969 and 1970, the crowds were already swarming. They were crowding around a wedge-shaped profile sitting just 44 inches off the floor, coated in a blindingly bright paint color the engineers called Weissherbst, or orange. With its top-hinged gullwing doors, attendees assumed they were looking at the direct, highly anticipated successor to the famous Mercedes-Benz 300 SL. The hype was so intense that wealthy collectors immediately started mailing blank checks to Mercedes headquarters in Stuttgart to guarantee their spot in line. Mercedes didn't cash a single one. They locked the prototype away and refused to sell it. The C111 was a laboratory on wheels. It was the first car ever designed entirely on a computer and the testbed for a radical new multi-link rear suspension that allowed each wheel to react to the road independently. Instead of sitting in a collector's garage, this single chassis would be used to solve three massive engineering crises over the next decade. Between 1969 and 1971, Mercedes focused entirely on their first experiment, the Wankel rotary engine. By the second generation, they packed 4 rotors into the bay, producing nearly 350 horsepower and a 9,000 RPM redline that deafened anyone sitting inside the cabin. Instead of heavy pistons pumping up and down, a triangular rotor spins continuously in a single direction, allowing for high-speed revolutions. But that cycle came with a severe cost. It guzzled fuel, and the combustion process pumped heavy, unburned pollutants straight out the exhaust. Raw performance could no longer survive incoming environmental regulations. Mercedes abruptly killed the Rotary project. In 1973, the global oil crisis hit. Gas shortages swept the globe, and the automotive industry was forced to prioritize fuel efficiency over horsepower. Mercedes took the futuristic supercar shell of the C111 and made a jarring pivot. They dropped a heavy, sluggish, utilitarian 5-cylinder diesel engine inside it. To force speed out of a tractor engine, engineers bolted on turbochargers, added an intercooler to chill the intake air, squeezing an uncharacteristic 228 horsepower from the block. To see how long the engine could hold up, they shipped the car to the Nardo Ring, a massive circular track built for high-endurance testing. The results shifted the industry. The car held an average speed of 210 miles per hour while maintaining 16 miles per gallon. The C111 proved that diesel engines could be efficient and fast at the same time. By 1979, the focus of the testing shifted. The engineers had maximized the engine. Now they needed to conquer air resistance. They reshaped the fiberglass body to achieve an ultra-low drag coefficient, attaching a massive front spoiler and twin tail fins to keep the rear pinned to the asphalt. To push through the final wall of aerodynamic drag, they abandoned the diesel and installed a brutal 4.5-liter twin-turbo V8. Back at Nardo, this final configuration shattered records, clocking an astonishing top speed of 251 miles per hour. By pushing the physical limits of aerodynamics and chassis stability, the C111 completed its evolution into a record-breaking machine. The wealthy buyers who mailed those blank checks to Stuttgart never got to own a C111. This schematic shows the multi-link independent rear suspension. By using 5 links to precisely control wheel movement, it provided the combination of handling and ride quality that defines the modern luxury car. The car also proved the efficiency of computer-aided design, cutting 4 months off the development cycle, and demonstrated the potential for lightweight fiberglass bodywork. And those grueling endurance runs in Italy proved that high-performance turbodiesels belonged in everyday passenger cars. Decades later, the technology tested inside that orange wedge is in millions of cars on the road today, proving that the most important vehicles a company builds might be the ones they deliberately refuse to sell.